Hello, welcome back. Last time I invented a device that I would actually find useful in real life, but I can't take it out of the game. This used a module that apparently does have a datasheet for it. Raven Dynamics. Recognize words quickly and easily with Raven Dynamics. Natural language solutions in a natural language world. Natural language control is a critical part of any modern interface, yet cost and complexity of implementation has slowed its adoption in low-power embedded environments. Raven Dynamics is about to change the state of affairs with solutions based on its newly developed Neem Slice technology. By pre-encoding words and phrases as sets of small slices, which are then associated with a hashed key, Neem Slice can positively identify a dictionary's worth of spoken content with an over 92% accuracy rate. Words and phrases are hashed into a 6-digit number. In this example, the words Raven and Dynamics are displayed along with their hashed equivalents. So I said something about how you could fit every word in the language into a 3-digit number. Why did I say that? Because these were pairs of 3-digit numbers. It's totally 6 digits. And you know, 1 million words, 1 million hash entries for words is plenty. Like, you definitely can get an entire language in that. Anyway, the Raven Dynamics NLP2 is the first widely available implementation of Neem Slice technology. NLP2 references an extensive built-in English language index that was created in partnership with top linguists, computer scientists, and product design experts. With its built-in microphone and audio pass-through feature... Oh, I see. Okay, right, of course. Audio pass-through feature. NLP2 will easily fit into your existing designs to add voice control to even the simplest device. Right, yes, of course. Built-in support for the English language with mapping to a predefined keyword list. Captures audio using built-in binaural microphones and processes spoken keywords as they are detected in the audio stream. Keywords are reported over XBus as pairs of 3-digit values and are buffered through an internal non-blocking buffer that yields a value of -999 when attempting to read when no data is available. As usual. Raw audio pass-through is available in addition to the keyword stream. Cool. So something I was thinking about is the way this implementation ended up working out. I really would have been better off with interleaved numbers than doing these separate lists. It did happen to work out well for power usage to do it this way, but like if I did 711, 573, 495, 160, when I don't get a match on the first one, I would probably just read to null for the second. If I do get a match, then just do the read and the compare immediately. That would mean... Actually, you know, that might be tricky, because then I'd have to have two... That might not save me as much as I thought it might. Because I still need... Yeah, I don't know. It's complicated. But yeah, so interleaved values in there might actually be more viable than I initially thought. Hey, remember the Cool Dad thing from a while back where he got arrested before he could start the tour and we got stuck with all these color-changing vape pens and it was kind of a disaster? Well, I just got a call from his people and... His tour is back on! They want the inventory! We don't have to dump them after all. They might even want more! I'm so happy right now! Finally some good news today. I was very close to telling the accountants to take a write-down on all of that stock. Hang on, are we sure this wasn't just some elaborate publicity stunt? You know, the old concert's off, no wait, it's on again ruse? No, just me? Alright then. There's a rumor online that Cool Dad was actually framed by his twin rivals DJ Like and DJ Subscribe. Okay. I'm fine. That's pretty good. Will we get any sort of special deal on tickets? Xiaomei and I would be interested in going. I don't know why that made me laugh so much, but it did. It was very good. Right, yeah, so they want the inventory. We already built it. There's no puzzle for me to do because it's already done. All the way back Where? There it is, okay. I thought it was farther back than it was. Still pretty far back. Would you believe it? So last night I met a designer for a major international athletic wear company. She was in Shenzhen to tour some factories. We had a really good chat and we went and got a couple of drinks together and, well, you know how it goes. One thing led to another, and to turn a long story short, soon enough we had a product idea. Specifically, automatic color-changing running shoes. Everyone loves brightly colored shoes, but matching them to outfits can be a pain. Shoes made from E-textiles could afford the rest of your outfit could adjust to the rest of your outfit automatically. Their design team sent over some colored data tables to get us started. Okay. Sure. Joe's all about the color changing. Button is a simple input connected to a button. Sensor is a simple input connected to a color sensor. Oh, okay. So this scans your clothes and chooses a complementary color to match. Ink K and Ink N are simple outputs connected to pieces of fabric coated with color-changing electrochemical dye. Neat. The future is cool. While the button is held, values from the color sensor should be read and bucketed according to the color classification chart. Let's go find that. Probably going to be supplemental data. Sector map, elegant bachelor? No, smart die, color space. Here we go. It gives me the light wavelength. Oh, and those are, I see what kind of range these numbers are in. I'm going to be working with those. Dot blood, Teeth Nacho, Chartreuse Abuse, Ballistic Viridian, Cool Dad, and High Purple. Cool Dad's got his own blue. All right. And that's the light wavelength, if you want to reproduce this color. But it's a range. Which exact wavelength is it? Cool Dad. N-axis, K-axis. These colors. Okay. When the button is released, Ink K and Ink N should be set to the bucketed according to the color classification chart. Min value, max value. I'm going to have to read the verification tab to get this. Set to the values corresponding to the color that most frequently occurred during the calibration period as indicated in the smart die color space. There will never be a tie. Okay. Prior to calibration, Ink K and Ink N should each be initialized to a value of 50 corresponding to a neutral color. Look in the supplemental data section of the manual to find the wavelength-based color classification chart in the Ink Smart Die color space. So, was it not? Is this sequence mode calculator? That's what that was called, wasn't it? Oh dear. I think it's relevant to mention this is not a day when I have a huge amount of recording time. And I'm feeling like a 2-hour puzzle coming on here. I might have to split this one up, if it's as nasty as I suspect. So sensor's always just going to have data on it. Initialize these to 50. While button is held, sample these inputs. There will never be a tie. So what's the most frequent value here? 55, 53, 42, 49... No, hang on. Let me read that again. Prior to camera. Read and bucketed according to the color classification chart. Okay, now wait a second. I think I get it. How do I output? Ink K and Ink N should be set to the values corresponding to the color that most frequently occurred during the calibration period. So I guess this is just where my... Oh, yeah, okay, there are the number values. I don't have to parse through the graph and figure out what they are. Okay, I didn't notice these were numbers. Okay, so here's my output values. Cool dad is 1580, high purple 7585, etc. How do you... KN, those are not familiar to me. You need 3 components for to get a full color gamut. You can't do it with just 2. How's that supposed to work? K and N. Like, yeah, I really don't know of any color space with only 2 components to it that is chromatic. I mean, you know, you could do gray alpha. You could do red-green, but then you wouldn't have any blue. You know, you need CMY or CMYK or RGB or something. But this does it with 2 somehow. Okay, so anyway, well, but light wavelength, that just takes 1, right? Hold on, KN, K, CMYK, that stands for black, the K in black, so N would be, oh, nanometers, okay, yeah. So you got wavelength and darkness, basically. Okay, no, that does make sense. Huh. Alright, well that's cool. But what about saturation? I don't know. This doesn't seem like a full color gamut to me. Anyway. So I'm still... I resized my browser window by accident. I'm still trying to understand... This is why it's hard to record browser games, because, like, just an accidental state change like this, that can occur during, like, normal computer usage, will mess up my recording settings, and I can't play browser games because of that. Okay, so, what you're looking for is... So say I get a 55 while the button is held. That means I add 1 point to yellow because that's in the 50 to 59 range. So I increase index 012 by 1. Then I get a 53. So index 2 goes up to 2. So obviously one of these is involved. Probably. Unless I want to, like, DGT, DST, this could fit in 2 3-digit values if there were never more than 9 samples. Theoretically. It's probably easier to just use one of each of these fields for that, though. There's no div instruction, by the way. 20, 40, 50, 60, 70, 80. I don't want a div. This is, So I guess outside of that sensor value, well, that's outside the range of visible light. So that'd be infrared, this would be ultraviolet. Yeah, infrared up here, ultraviolet down here. So just ignore those and don't increase any of those. So am I just going to have, like, actual 6 TGTs or TLTs? Because again, there's no div command. There is with a math coprocessor, but I don't get access to that for anything other than prototyping, right? MC4010, math coprocessor. This part is for prototyping only. Yeah, and this does have a divide. I have not gotten to work with that yet. Okay, so anyway, red and bucketed according to the color classification chart. Yes, alright, I understand. When button is pressed... when the button is released. So on falling edge, I don't care about rising edge, but while held, increase the numbers. I guess on rising edge, set to 0. And I could do that on falling edge too, whichever way is more convenient. On falling edge, check the index of the highest and use that to read a pair of values from somewhere, presumably one of these. Okay, so let's try this. Alright, so blood, 95.5. I keep wanting to tab to the next one, but I have to enter. Tab shows me the back of the components. Hold on, I don't have a div, but I do have a mul, so I can mul by 2 to get the initial index, then just read the next 2 values from the most frequent index in here for this, sure. Okay, so deep nacho, 55. Oh. Chartreuse abuse, 55. Ballistic Viridian, 560. Cool Dad, 1580. Oops. High Purple, 7585. Okay, those are my output values. Okay, so tasks are listen for button, bucket values and increments, find highest index, and then use that for output. A lot of 5s in a row here. So 50 and 5, 5 and 5, 5 and 60. Yeah, they are unique. There's room for one more, if you want one more. Okay, so what I want to start with is frequency mapping. Seems hard. Yeah, you're in my way, little thingy. So while button is held, see, I need to detect falling edge though. Well, someone else can do that. Your job is just that. TLT P0 40. Will the sensor detect infrared? Let's assume for now it doesn't, and just say that 0 to 19 correspond to red, and 90 to 100 correspond to purple. That seems fine. TLT P0 40. Oh, 40 plus move. I don't like this. This is not going to fit. So let's say that's the address line. (0x3). Let's see how close it gets to fitting. Minus TLT P0. Next one is 50. $60. Oh, not 0. None of this is right. Because, like, if it is less than 40, then you're going to move all of these values at once. Okay, so what I'd want to do is do this backward then. TGT P0 19. Oh, actually... no, that's right. TGT P0. So, like, this is going to do a bunch of redundant work. But it will at least have okay data integrity. Okay, so next is 49. Oops. 59, 69, 79. That's actually not incredibly close. Sorry, incredibly far off. I think I can also minimize that a bit. Can't the last one of these have a minus case in it? So maybe this did fit. Tag P1100 minus jump weight. Yeah, okay. So if I remove this, or if I remove this... No, that doesn't work. Hold on, but what I can do is nothing. No, I can't do what I wanted to do at all. Well, okay, so here's a thing I can do. I can have you awoken by somebody else. Somebody else listens to the button, and when I awaken you, you read the sensor and maybe write a whole bunch of address values, but eventually... yeah, okay, that seems pretty plausible. Alright, so how that works. Alright, you're not going to read the button. You will be responsible for the sensor. I don't know if X0 is the way to go here, but let's do X1. Just going to go ahead and put another 6,000 right now. Well, this is not the most convenient thing in the world. Yeah, I don't like the way that I/O works out, but you know what? It's fine. Maybe. We'll see. So, idea would be... okay, so X3 needs to connect to the address line of this. And address line. That's fine. I'd rather you connected to the other one. And I can do that. Well, not like this. Okay. I just don't like the way these pins are working out. I can do that, which I also don't like. Ah! And yeah, and P0 doesn't go then. I just feel like I'm wasting so much space in so many places here. I mean, this doesn't need much I/O. It really does not need much at all. If your X0 goes to the Yeah, your x0 is going to go to the a0 here. So these all change to x0. Those are all x1. Okay, so x1 is how you communicate with that. So you wait for somebody to request that you figure out which address to increment. Tech p0 100 plus move. Okay, so problem. I'm not clearing the IO line here. And I can't move x1, x1, can I? Maybe I can. So if I move 1 to x2, can you read it and then write it back out? Oh, Pernat's leaving first. It didn't, I mean, it compiled. Oh yeah, sure, and you gotta initialize those, that's fine. So I write a 1 to you, that one's gonna go all the way in here and then be spit back out, and then I'm gonna use it to add to that value, and that's fine. Well, now, move 0, x0, yeah, so your sample is 55. Move 1, x0, move 2, x0. Okay, so you got to that index for a 55, which is correct. Okay, great. So that's the yellow index. You skip over the rest. And then you read that and write it back. Neat. Okay, so that totally works. I remember doing a trick like this in TIOS 100 before. I'm glad to see it's still alive here. Alright, so how would I do the rest of this? I guess really I need to wait for this before reading the value. So I do just need to discard that. Because this task here can't happen until... Hold on, I don't want the address here, I want the data. Move x3 ACK, add 1, move ACK x3, and then you need to mess with the address line. Oh boy. And you're gonna have to communicate to somebody else eventually, so it'll have to look like this icky mess. At least you don't need another simple pin. Alright, so your x1 is coming off, and that's what's going to tell somebody else to do something. Who are you going to tell to do something? Maybe you're not. Someone else also needs to listen to button, and I have a wire snarl here that makes that impossible, don't I? Maybe not? Oh, and dat. Okay, you can detect falling edge on this, I think. You can store... Yeah, okay, so... I think this might all be possible. First, before I do anything else, let's see what this does for sampling all the stuff. Is it just me, or is it not adding enough samples? You should have gotten a whole lot more. Something went wrong. So I saw it put the yellow in there. Here's yellow. Move x1, x1. Move x2, null. Move x3, ACK. Add 1. Move ACK x3. Doesn't matter where your address pointer is right now. Alright. In the next one, we're going to get a 53. Wait, why is that there? Oh shoot, I need... reading advances at... so I need to go back to... Oh, really? Oh, really? So if I want to read and then write... That's annoying. I don't like that. And yeah, that's why, right, my values were just getting overwritten. That's why they didn't all show up. Yeah, because you read that, and then you wrote the... How would I do this? I could set both sides of the address to the same value, then read from one data, write to the other one. I don't like that much. It's plausible, though. It does mean you'd have no means of communicating to the outside world, which might be okay. Well, it's not, though, because this button wire has to go somewhere. Somebody has to detect the falling edge and actually commit the ink. Oh, boy. Okay, so is this a fundamental problem? I can't really repeat this value if your dat is... Oh, well, okay, fine. Let's do this. So your x0 is the address line. Before you read x3, move x0 to dat for now. Move x3 ac, add 1. Move dat, x0, move ac x3. Okay, so at least this should sum up the values correctly. So 1 yellow, 2 yellow, 1 something else. I see a number increasing every time. So this color is supposed to be... chartreuse abuse. 5555. Yes, okay. Alright, well, so counting those works. Yeah, so that works. So that's fine. This x1 line is going nowhere. Okay, so... Thing is, if I'm using dat for that, I can't have you detect the falling edge. If someone else detects it, how will they know when you've done your work? Well, what if... Oh, now hold on. Oh, this is interesting. Oh, I see a way to do this. I got something cool here. All right, so, FE, falling edge. So I don't think I have enough instructions here. So if you are... If P0 is 0 and AC is non-zero, then I know it's a falling edge, because if I set AC back to 0, once we get here, move a signal out the x1 and set AC to 0. Okay, and actually that can just be plus... Okay, yeah, so this is neat. I think this actually makes sense. So if button is not pressed on the first tick, AC will be 0, so none of this will happen, so you'll just sleep 1. When button is pressed, you do your stuff as normal, and you jump to wait, so I skip all this extra code. When the button goes from pressed to unpressed, it lands here, and tests if AC is 0. It's not, so then it'll send a thing out in X1. Cool! That works great! Yes! Alright, I'm happy with that. And it all fit, and I even have an instruction to spare. And then you reset AC to 0 to, so that on the next tick you won't also wake the downstream stuff up. Okay. Can I compact this at all? I think I can, not with those bridges in there. Can I get rid of those bridges? Unlikely. Nah, I think I'm good. Okay, so downstream from there. All right, yeah, I think a phase of this program. Oh, somebody's gonna have to reset this at some point. That's fine. I can do that on Falling Edge. You don't have room. You don't have room. Someone else is gonna have to do it. Let's see. What's going to be convenient here? I don't need any simple pins, so that space is fine to occupy like that. You're not using your things. There's no way you'll access... Oh, hang on, I do need simple pins. Ink K, Ink N. Well, there's no way this microcontroller is going to be able to do everything, is it? I don't know. Let's find out. Alright, so without worrying about wire routing, let's figure out the tasks here. So, SLX X3. Cool, this will be nice and efficient. It'll always sleep except on button falling edge when it actually has a job to do. Alright, great. Yeah, okay, so your job is reporting frequency. And that's fine. I know how to do that. Yeah. This will be good. Okay. So, yeah, with the 2 registers, this will work just fine. I know exactly what to do here. Yes, this is good. While measuring frequency, you can also set everything to 0, I think. Okay, this is fine. Is it? I'm gonna have to count to 6, and that might be hard. In context, that makes sense. Because I don't have an extra register for it. I have plans for both of you. Okay, so when you give me a ping, that value is meaningless. I do need to discard it. Well, but maybe I could have... Maybe I could do something with that. I don't know. For now, I'll just discard it. Okay, so measure frequency. Address is just going to start at 0, so... Yeah, I have to count to 6, and that's going to be hard. Alright, so the familiar loop structure... That's the for loop. Here's the payload. So my plan was going to be something like move... actually... Since I need to do some conditionals inside this loop here. My plan was going to be, before I was counting to 6, move x0, the data line, to AC, TGT ac dat, because dat was going to keep the highest, the most frequent one in there. If it's greater, then move ac dat and move. Oh boy, I need another register here. I need to know the I need to know both what the greatest value is and what its index is. So really I need 4 registers here. I'm not going to get that. Do I need to know its index? I think I don't, actually. See, I mean, I'm already overwriting my ACK register, so this is no good. I can't have any marker values here because these have to start at 0. I could init. Oh wait, I can test the address. I can test the address. Yeah, okay. This does this. The pointer over here is going to do my counting for me. Here we go. I don't need to put 6 into ACK. That's better. So that's going to be tech x0, 0, 1, 2, 3, 4, 5, 6. If it is, then jump to end. Okay, great. And I don't sub 1. Nice. That's much better, of course. Yeah, so you do my counting for me. So move x0 ac, tgt ac dat, plus move ac dat, and then I need to move the greatest index somewhere. Probably just set a simple pin. I'm super out of space here, I note. Can I sneak some more in by, like... Yeah, if you never read x1, then that works. I don't love it, but that's what's happening. Well, now I can't access your simple pin, and so somebody else is gonna have... This is... I'm totally out of space here. But the idea would be... Move x1... Oh yeah, x1, right. The x0 is the data line, 1 is the address. Move x1 to p1. Then you need to talk on xbus to somebody who's going to sit here, actually, and that's almost fine. The problem is I can't simple pin because both of your simple pins are not on board. Oh no. Oh, layout become impossible. Technically, if you don't ever use x2, but you want to use x2. Technically, if you don't use x2, I could do this, but you want to use x2. Oh no, pin type mismatch, never mind. That still doesn't work. Okay, so part not on board. I think I have something good going on here. It's just that physical space constraints are kind of severe. Do I see a place to save some... Could I, like... Okay, so I don't have a lot of wires going behind things here. So first of all, that saves nothing whatsoever. In fact, that just occupies more space. Yeah, okay, so you can't go left because of those unless I were to... No, I still can't. Could I have this go to P1 instead of 0 and save something somehow? Let's see if x0 is doing that. Looking at all this empty space here. Like I'm just losing so much to wiring. Alright, what's my plan? Let me articulate my plan before I decide that I don't have enough space to do it. I know I don't have enough space to do it, but still. Even so, let me stick with a plan here. And this still might actually be almost possible, except for this. Except for this. The fact that I can't do that. Okay, so what's the plan, Alex? What are you doing? At the end, all I do is signal on X-bus somewhere. Actually, I'm going to move the X3 to save an instruction to X2. So your wake-up signal that you received on X3 gets passed on to X2, which will have a connection to the simple pin somehow. But it can't do that because I need 2 simple pins for this. And that's just sad. Well, okay. And then you would read your simple pin and know which index to use. You'd have to subtract 1 from it, but that's fine. You subtract 1, mul2, write it to the address of this 200p14. Read that value, put it to inc k, read the next value, put it to inc n. Or the other way around? 15 to K, 80 to N. That's cool, Dad. 15 to K. Okay, so read that value, put it to K, read the next one, put it to N, okay? So if you had 3 simple pins, like if it looked like this, and this were an X-bus here, it still wouldn't work, because I would need access to this if this were a simple pin, and that would have to go there. Okay, so even with that, that is insufficient. I can't DX300 this because it needs exact values. I mean, there's still a bunch of room on the board. It's not, I'm not completely out. Okay, and I might be able to sneak something through. Okay, here's a way to save some space. That's the beginning of something. Maybe I can connect that. Alright, that's nice. This is okay because this is a write. Writing to the data line for this means nothing and I'm not using that. Hey! 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 Things fit, suddenly. That's promising. So then to make this all work, all I would need is just an MC4000, which expands one X-bus line to 2 simple I/O lines, and I think that's possible to do. Here's simple number 1, here's simple number 2, and X-bus will have to go, you're not using X2, so that has to get over to that somehow. Okay, but I think I've convinced myself this is going to be possible. This X3 is connected to something. Okay, so you'd go to, say, the X3 here. This X2 would go to a dude down here. This is getting so tight. Yo, I don't like it. That won't fit, because how will I ever get that P2 anywhere? I won't. I can't. Okay, well, I'm almost there. I'd love to skip this step, but I don't have enough simple pins for it because I'm using a simple pin for communicating this. Do I have to? I don't have any storage left. I'm using AC and DAT. Well, what if... No, I can do this. I can do this without the simple pin. That would mean I need to free that simple pin for use with this. Which might... let's see, okay, how would I do that actually? Like this? Nope. Nope, to get to ink N now is a little hard. Okay, so X3, so you're just never going to read from X0. X2 will be your communication line. Okay, I think this works. P0's got a route in there somehow. Okay, so P0 will go to ink K. P1 will go to ink N. Okay. Okay, so the idea, there's going to be a little bit of inefficiency here, but I think that's okay. This value that I'm sending, let's make it positive 999. It's not a nothing, it's a, that's your end. So move X1 to X2. X2. When you get a value that's not, when you get a value on X1 that's not 999, you're going to sub 1 and stick it in DAT. No, you're not. You can do something different. Move X1 to DAT. Take AC 999. Let's move that AC. All right, yeah. So when you receive any number, yeah, this is going to wake up multiple times in one cycle and store a value that's sent to it in DAT. So this avoids me having to use this simple pin. It's it's not that much inefficiency. It's fine. So move X1 to DAT, tech DAT 999. Move that AC, jump weight, and you're going to hold off on the sub. You don't need to sub every time, not until you actually have the real value here. Okay, so sub 1, mul 2, move. I gotta route these to those. Eesh. Ooh. I don't think I can. With this layout. Because I want to move AC to X3 and have that connect to the address line. Because I can do this. Yeah, I can technically do that much. Well, actually, no, I can't even do that much. Because, yeah, there's no way to route both of those in there. I can't put this down here because that's where the simple pin is, which is doing that. I can go one more to the right. Maybe that'll save me. Because if I can fit this down there... I can go one more to the right, right? I totally can. That minimizes the space used by that nicely. No, that makes X3 unusable. Because it's right next to ink N. What's this section of wire? That's nothing. Oh no, that was bridging these together. Can I take an extremely circuitous route? Yes, I can! Oh, this is funny. That would go through... Okay, so now you could route differently. You're not using your x3, so I can do that. Doesn't help. Does it? Oh boy, can I change? No, I can't. Can I move you down? No, I don't think so. So yeah, the fact that I'm not using my... Oh no. This opens up... Oh no, it opens up nothing. Never mind. Okay. So, this is where we're at. Doing some silly stuff. How do I get this x2 somewhere? The somewhere that I want is into this address line. Is there some super circuitous route I can take to put those together? Not here. I can't go behind this because that has to connect to X3. I can't connect it to one of these because those are... It does need both address and data lines for that. That needs to be there. This layout is just kind of locked in. I can't do surgery over here without changing everything. I'd love to be able to... So undo this change, put this back over here, and stick this down here. But that it doesn't. It doesn't work because I need that simple pin there. And I need that simple pin exactly there. Like, this is where this fits. But I have to connect this wire, or disconnect this wire. Right, again, so I can disconnect that wire. But where could that possibly go? Really nowhere. So that doesn't accomplish anything. Oh wait, no. No, I can't do something like this to have x2 be that. Because I still need, oh, it's just, I just need a tiny bit more space. How can I get a tiny bit more space? So much of this is so close to fitting exactly the way I want it. But I just have too many wires on the board. If I could bridge here, then we might be in business, but I can't. Because yeah, you're not using your x3 or x2, so I can go right through them and it's fine. I just see this big unused channel that leads to where I need to be. Almost. But not quite. Well, if I can't solve the wiring problem, I'm gonna have to do something else, so let me just really try and solve the wiring problem. Okay, I think I see one possible hack that could do it. I don't love it, but I have an extra instruction over here. This is communicating over this line that goes there. What if this went there, you never used your x3, and this x0 went to the address line? Now, what's tricky about that is it means this x1 is going to two places. I'm going to repeat these values. It needs to be the same value. I'm going to make it 998. You're going to move x3 ACK, add 1, move AC x2. It feels a little bit silly, but that's what's going to happen. You will... So you're sleeping on that line. You're just going to do something nonsensical. I don't even have to test for the 998. You can just do something nonsensical. Actually, now, hold on. No, I do want to test for 998. Tech dat 998 plus jump weight. That's fine. Is it though? Do I have enough instructions left to do the rest of this? I might need to make this a value that just has this do like a no-op sort of thing. And I think that's what I'm going to do. Like this add one, why would I do that? Okay, so I'm moving a bunch of zeros. You're going to get some zeros, you're going to do some extra work once again, and that's okay. Don't worry about it. And you can actually just... move x3 to null, because I can't... it just doesn't make any sense otherwise. End is just move 999 x2. Okay, so we're not doing this. You're going to get a garbage instruction. Because I don't think I can control who gets the instructions I put onto that XBus line. But if I put two on in rapid succession, they will reliably both get them. You'll get one and do basically a no-op. And you'll get the other one and wake up and do your work. And then some time later, you'll get the real instruction from that. Real instructions. And then the end value, and you'll actually do your work here. Great, okay. And this does all route, right? So x0 is now my address line, x3 is now my data line, and x2 is nothing. Neat. So move AC, I sub 1, I mul 2, I move AC to x0, I move x3 to... it was k first and then n? Yes. Move x0 to p0, new x3, the data line, to p0, and then I move x3, the next address, because the pointer advanced, to p1. And my program works perfectly first try, right? Somebody's not sleeping. Why? x3? Okay, so first of all, I have the wrong value. Okay, yeah, so I just have the... Well, you shouldn't be waking up. Ah, there's something on x3 because it's attached to the address line. So right, I just didn't update my pin numbers here. So all x3s turn into x2s. x1... Move x1 to x1. Move the address to x2. Yes, that's correct. Move 999 x2. SLX x1. Yeah, okay. So, right. Still wrong. SLX x2. Why does x2 have input right away? Because it connects to the data line, but I can avoid that. I actually have a fix for this. By not routing through there, that should work. Okay. Okay, so everything's good. No, it's not. Okay, not everything's good. It did it once. I do need to initialize the values, but that's fine. I can just do that here to fix that problem. Move 50 P0, move 50 P1. Oh, no, nobody wrote the zeros here. Okay, you can do it. Let's just write all zeros to that. Move 14 to AC. Loop 2, tech AC 0 minus sub 1 minus jump loop 2 minus, I'm out of instructions because I need to move a 0 to the data line to x0. Do I have a redundancy in here? That's not a redundancy. I can't move x2. Yes, the same line that communicates to both. Wait. Once again, I can use this pointer to do that. Yeah, okay. I clear the first 6. Okay, so move. So I don't use AC. I'm going to move 0 to x1. Loop tech x1 6 minus move 0 x0. So that should reset it to 0. And then jump loop 2. Okay, so we knit it to 50. Taking samples. Do I really want to watch this work? I saw that it works. So you know what? No, I don't. Let's just see that this reverts to 0. It did. Okay, and this should all work. Well, it didn't. Okay, so something's still wrong there at that place. So second time you've taken all the samples. Most frequent is 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. So cooled add. 1580. 1580. So what goes wrong? So here comes a wake-up signal for both of you. You discard it, you check it for stuff and do some garbage value operations, it's fine. Is this address pointer here a problem? Probably. Why are you all the way down there? Oh, shoot. Yeah, I need to oh. Okay, I can do this. Watch. Here's how this will work. So loop 2, you're going to have the move 0 to x0. Then I'm going to tech my paste didn't go because of a new line. x1, 0. So you loop all the way back around. It's not efficient, but it should work. You loop that second address pointer all the way back around because I... Oh wait, no, that's no good. Because I'm just writing from wherever I am, which is going to be at 6. Oh, what about... Oh, here's a sly way to do that. Alright, so check this. Move x2, x1. So that's where you set your address to 0. Sounds great. I like it. It's going to work fine. It didn't. It actually deadlocked. No, I breakpointed. It still didn't work. Okay. No, breakpoint there. So, that address pointer is there, but that's fine. So 0 goes in there. You set... Wait, x2, x1. Yes, okay, you set your address to that. Tech x16, it's not. You're doing a garbage operation, it's fine, don't worry about it. Move x0 ac. TGT dat. Oh, I didn't reset dat to 0. That's my problem. Okay, so this needs to be... Okay. I do need to reset dat to 0. I think I can find a way to fit that in here, but how? It feels better to me to have this move that 0 into dat, and at the end to have that address end on 0. So you're gonna go all the way through it. You'll land on 6. Yeah, there's really no way that from 6 I can loop around, hit 0 through 5, set them to 0, and then land on address 0. Other than by doing something like that. So I need to eliminate a line here somewhere so that I can, or have somebody else set this address line to 0. You're not using your x2, but I mean, I don't have ways to route that in there. That's just never going to happen. Like I had enough of a wire nightmare before. You're not using your x2, but you're using all your instructions. You're using all your instructions. You're using all your instructions. You got 2 spare instructions. It'd be great if you could do that somehow. There's no way you could, is there? There's no way to put a bridge in there anywhere, so you'd have to wire through... Oh... Yeah, I could destroy this address pointer, and that'd be totally fine. If someone could write to this line, just send a 0 in there after this is done, and that someone would be you. If I could just like put a wire jumper from here to here. That's the only thing that's missing. Okay. There's no way I'm gonna get rid of a line here, is there? X2, X1. Okay, so you need absolutely every line in here, right? So this resets your dat to 0. You're doing a lot. This does a lot of things, and I'm kind of surprised I managed to fit them all in here. Tech X1, 6. Jump end. You do need that jump because I need to do conditionals inside my for loop. Move x0 ac, tgt ac dat, move ac dat. Yeah, because I need to keep track of the value of the highest one. Its index is kept by you, kind of. Move x1 to x2, x1 to x2, yeah. Jump loop. And move 999x2, so it tells this to do stuff. Then it does its ending tasks. I just need another one of these. Tech X1, 6. Move 0x0, jump loop 2. And then once it falls out of that, it goes back to SLX. Yeah, no, there's no room there. But there's no wire room to have anyone else do it. The only way I can think of that ever happening is by, like, one of these going here, but how would it know to wake up? Because, yeah, I could wire from that to the X3. It doesn't matter if I output to the A0. Ooh, I wonder if this would eat my output. Well, I could wire it to the X2, and this would never read. This is read-only, so it would never read itself. I can't write to it. So writing to something that overlaps this pin would definitely safely write to there. But how would you know to wake up and put that 0 there? And I'd love not to have to put another extra entire microcontroller just for this one single instruction that I have space for here. If I could just wire your X2 to this. Which I could do if I did this. But that has other problems. So the wires route. The wires do actually route. It's just that I can't then SLX on the X2. Is there any way around that? No, because you always have something you can write, and so would this. Like, routing through here instead would do no better, because your SLX would go off immediately, always. The only way to avoid any actual data coming through here is to go through this. So yeah, that's just not something I can do. But this routes so nicely. Well, it doesn't matter, because it doesn't work. Just like snip these pins off. There's got to be a way. Oh, I think I might see one. Okay, so without changing my wires, a way to sneak away in... I can't get another line in here. Like, this is completely full of every line that absolutely has to do stuff. But if I move 1 to X1, so you'd start here, and do this little shuffle again. So I'll cut that, put that there, and put the test there, so that you always write before you test where you are. No, it does move 0. Okay, so you'll start at 0. You'll write a 0, advancing the address pointer to 1, so you read it and it's not 0. Then you keep on going through it until you write this value, at which point it is at 0. And yeah, okay. So just by carefully bracketing my boundaries here, yeah, it's inefficient because it has to write a bunch of zeros to get back around here. But pin is not connected. Oh, right, okay. I added that instruction as if I was going to route that. Okay, so what do you think? I think that came back to 0. Alright, 0 comes out. You wake up. This one is also going to wake up for a moment and do something nonsensical. Okay, that is 0, so I did reset it. You're reading the frequency tables. You know how to do it. And yes, you did start from 0, so yeah, I mean, this is all just going to work. It's all just going to work. It's perfect. It's perfect. I did it. Like, I don't need to step through this program. I went through each step carefully as I typed it, and I typed it correctly, and verification says it works great. Yay! My graphs are all slightly subpar, but I'm satisfied with that. Yeah, when I run into situations where physical space is this constrained, and I have this many things on the board that are this full, I know I'm in a suboptimal solution, but it's not suboptimal by that much. Just a little bit on each thing. This is actually pretty cool, Joe. Maybe even more kinds of clothing could be next after shoes. Personally, I'm thinking we should apply it to tracksuits next. It'd be sweet if I could have a different color for every day of the week. Alright. Yeah, I don't really have a lot of thoughts on how to improve this. Like, the design makes sense. It all works. I don't like this, but I don't know how else I'd do it. There are a bunch of little inefficiencies, like having to write the entire table, but like, I just ran out of room. Like in every way, I'm just out of room. This is an absolutely full circuit board. And like an absolutely full circuit board still did that well. You know, it's not great. It's fine. It's fine. Yeah, I'm okay with this. Like, yeah, if I came up with some fundamental way to improve this majorly, then I could maybe be open to a redesign. But right now, I don't have any on my mind. This is fine. This is fine. All right, cool. I'm happy with that. And I'll see you next time to read some more spam. Oh boy.